And we are talking about proofs in algebra and geometry. This is just an introductory lesson, and we'll be doing more with this later on. A proof in mathematics is an argument that uses given information, postulates, definitions, properties, and previously proven statements, often called theorems, to show that a conclusion is true. In this class, we'll be focusing on two-column proofs and paragraph proofs right now, but later we'll examine indirect proofs and coordinate proofs. To succeed in proofs, you'll want to remember the properties of equality. Addition property of equality, we can add the same number to both sides of an equation. This also holds for subtraction, multiplication, and division, as long as we do not divide by 0. The reflexive, symmetric, and transitive may benefit from some review. The reflexive says that x is equal to x. Symmetric says that if x is equal to y, y is equal to x. The transitive says that if x is equal to y and y is equal to z, then x must be equal to z. A little arrow. And substitution says that if x is equal to y, then we can substitute y in place of x. So moving on from there, we also have the properties of congruence. These apply to segments and to angles. The reflexive property of congruence, for example, says that the segment AB is congruent to the segment AB. The symmetric property of congruence says that if the segment AB is congruent to the segment CD, then we can write this in reverse. CD is congruent to AB. This will just help you get to the correct final statements in your proof. And finally, the transitive property of congruence says if AB is congruent to CD, and CD is in turn congruent to another segment, EF, then AD would be, or AB would be congruent to EF. So those are our properties of congruence, and we can rewrite these with angles as well. Things to keep in mind, some definitions. If the measure of an angle is equal to 90, then it is a right angle. If two angles sum to 90 degrees, then the angles are complementary. If they sum to 180 degrees, the angles are supplementary. If B is the midpoint of segment AC, then segment AB is congruent to segment BC. There are two other types of angle pairs. A linear pair is made up of two angles that are adjacent and whose non-common sides are opposite rays. So in this drawing, angle 1 and angle 2 are a linear pair. Vertical angles are our other type of angle. They are made by two pairs of intersecting opposite rays. They have a common vertex and no common interior points. They do not share a common side. Okay, your steps for writing a two-column proof. You want to write what is to be proven, draw a diagram if needed, state the given information and mark it on the diagram, plan your argument and prove the conjecture. The last statement in your proof should be what is to be proven, followed by the reason why. So once you write that final statement, you should not be writing additional statements. It is important to justify each logical step with a reason. You can use symbols and abbreviations, but they must be clear enough so that anyone who reads your proof will understand them. To get from your hypothesis to your conclusion, you can use definitions, postulates, properties, and theorems. Once you have proven a theorem, you can use it as a reason in later proofs. Here's an example of an algebraic proof. We are given 2 times 3x plus 5 equals 40, and we're going to solve for x. So we start with our given statement. We use the distributive property. We use the subtraction property of equality to obtain 6x equals 30, and we use the division property of equality to show that x is equal to 5. So this is a simple algebraic proof. Okay, the same thing here. We can solve for x justifying each step. So we're going to start with given, and then we're going to just adjust this. 1/2 x minus 6 is equal to 12. That's the addition property of equality. I added x to both sides. I'm going to use the addition property of equality again to obtain 1/2 x is equal to 18. And then I'm going to use the division property of equality. I'll divide both sides by 1/2, and that will give me x equals 36, and that's the division property of equality. So just some quick algebraic proofs there. Now here, we are starting with, we're going to prove, given that B is the midpoint of AC and that AB is congruent to EF, we are going to prove that BC is congruent to EF. So B is the midpoint of AC is a given statement. So I'm going to start with what's given. I'm going to say that's given. AB is congruent to BC. Well, that's definitely true because that is the definition of midpoint. BC is congruent to EF. Well, I was told that, AB is congruent to EF. I was told that. That's another given. Now, if you look at your statements here, and I'm just going to change colors. So I had given, definition of midpoint. And another given. I have AB equal to BC. I also have AB equal to EF. So I can use the transitive property here to say that because BC and AB are both equal to the same segment, BC is equal to AB, or is congruent to AB. EF is also congruent to AB. Since they are both congruent to AB, I can say that by the transitive property of congruence, BC is equal to EF. Okay, so I've proven that BC is equal to EF. Moving on from there, I want to write a proof. I am given the measure of angle ABC is 90. So this angle here, 90 degrees. And I'm also given that measure of angle 1 is equal to 4 times the measure of angle 2. I need to prove that the measure of angle 2 is 18 degrees. So I start off with both of my given statements, and it is okay to write both your given statements at the beginning. The measure of angle 1 plus the measure of angle 2 equals the measure of ABC. That is the angle addition postulate. Then I am using the substitution property of equality here. As you can see, I have replaced measure of angle 1 with 4 times the measure of angle 2, and measure of angle 2 has just stayed the same. I've combined like terms. To get that 4 times the measure of angle 2 is equal to plus the measure of angle 2 is equal to 5 times the measure of angle 2. And then I've used the division property of equality to obtain my statement that I wish to prove, which is that the measure of angle 2 is 18. Okay, some theorems that will be of help to you, and these will be provided both in the Google Classroom and they'll be printed out for you as well. If two angles form a linear pair, then they are supplementary. The congruent supplements theorem says if two angles are supplementary to the same angle or to two congruent angles, then the two original angles are congruent. The right angle congruence theorem says that all right angles are congruent. And finally, the congruent complements theorem says that if two angles are complementary to the same angle or to two congruent angles, then the two angles are congruent. So let's start by proving the linear pair theorem. If angles 1 and 2 form a linear pair, then angles 1 and 2 must be supplementary. So as with all of our other statements, we are going to start with the given. So angle 1 and angle 2 are a linear pair. That's given. We know that angle 1's measure plus angle 2's measure adds up to the measure of angle ABC. And that is angle addition. We know that angle ABC is a straight angle because it is made of two opposite rays. That's the definition of a linear pair. And therefore, the measure of angle ABC is 180 degrees, and that is definition of straight angle. Therefore, the measure and I just ran out of room there. So the measure of angle 1 plus the measure of angle 2 is also 180 degrees, and that's the substitution property. And therefore, angle 1 and angle 2 are supplementary. And this is the definition of supplementary. So that's our proof of the linear pair theorem. In class, we'll be proving congruent supplements, congruent complements, vertical angles theorem, and the right angle theorem as well. Okay, now a quick two-column proof here, we're given that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. We want to prove that 1 is congruent to 3. So I'm going to do this as a two-column proof, statements and reasons. I'm given angle 1 and angle 2 are supplementary. That's given. Angle 2 and angle 3 are supplementary. That's also given. Therefore, the measure of angle 1 plus the measure of angle 2 is equal to 180. The measure of angle 2 plus the measure of angle 3 is 180. Both of these, by definition of supplementary. We can then write that the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. This is substitution. We can then subtract measure of angle 2 from both sides using the subtraction property of equality. And then by the definition of congruent, we obtain that angle 1 is congruent to angle 3. Okay, so another proof there. And I hope that's been a useful introduction to proofs in algebra and geometry.